Good morning, Dr. Shivkumar. Welcome to the first keynote speaker, Dr. Shivkumar Kalyanaraman. Dr. Shivkumar Kalyanaraman is the CEO of Anusandhan National Research Foundation (ANRF), leading India's strategy for advancing research and innovation across academia and industry. Formerly, he is the CTO for the energy industry at Microsoft Asia. He is a fellow of IEEE and INAE, and a distinguished alumni of IIT Madras and Ohio State University. So with that, the stage is all yours, Dr. Shivkumar. So you can go ahead.
Okay. First, thank you, Sashi. Thank you to the audience, and sorry I couldn't be there in person. But I'm very happy to share with you a little bit about Anusandhan National Research Foundation and what we are doing in the space of AI intersecting with science and engineering. And and also I understand that there is a combination of academic and industry audience today. Again, I have just over the weekend I've written a very long article on what is ANRF, what is RDI, how can individual entities, whether you're an Indian company, whether you're a startup, whether you're an MSME, whether you're a global capability center, how can you partner with ANRF? If you'd like to read that, I would urge you to scan the QR code over here, which is my address, my LinkedIn address, and or just look me up my name on LinkedIn, and you can see my articles there. And without further ado, I will give you a brief summary. First, ANRF is a statutory body of Government of India, presided by the Honorable Prime Minister of India. Okay, this is very, very special. First of all, when Nandan came to Aadhaar, there was a statutory body called UIDAI. Similarly, in my role here, so I lead ANRF, but this is a statutory body of Government of India. Statutory body means that it is set up by Act of Parliament. We have an ANRF Act 2023. Statutory body also means that it's an independent body of all the ministries. So while we have one of our departments, which is Department of Science and Technology, which is our administrative ministry, my reporting is to an executive council, and then from there to a governing board. These are two boards, and these boards, the executive council is chaired by the principal scientific advisor, who's part of the PMO, and then the governing board is chaired by the Honorable Prime Minister, and the two vice presidents are the Minister of Education, Minister of Science and Technology, and it is there are a number of secretaries of scientific departments, things like ISRO chairman, DRDO chairman, DST secretary, DBT secretary, DHR secretary, etc., and CSR, and so on and so forth, and as well as some other secretaries like Secretary of MIT, Secretary of MNRE, and so on. There are also since I'm speaking to IISc, the director of IISc is also part of my board, and director of TIFR, and so on. So anyway, the full details are there in the ANRF Act if you're interested. Okay, but with that, I will talk a little bit about ANRF. I'll also talk a little bit about our how we do mission mode programs and the specific mission mode on AI for science and engineering and why it's so timely. Okay, and so ANRF in a single slide. This is the slide I typically use to describe ANRF. We support research across the spectrum. So think of us as a combination of NSF and DARPA, but we have a larger agenda than that. We are, I would call, a general purpose mechanism used by the Government of India to drive funding into the research and innovation ecosystem. We are incremental to many of what the departments have been doing already. So this is incremental investments, and we do foundational transformation of the core research. We fund basic research, we fund applied research, we fund translation research, we fund research. We're going to be announcing many new programs around societal innovation. We fund research at the intersection of social sciences, humanities, and science and engineering, and so on and so forth. So all of these are what we call ANRF core. In addition to the horizontal foundation that we lay, we also do vertical programs which are more mission mode, like DARPA style programs. And AI for Science and Engineering, one of those kinds of programs. It has a bit of an NSF and DARPA feel to it. So those are all grant programs. Okay. So the second portion of ANRF is a capital program. The difference between a grant and capital, first important thing is to realize that a capital program is not, I repeat, not a grant program. A grant is when I give you money and I don't expect it back. Okay, of course, I might have milestones and I might not give you the next grant installment if you don't deliver. That's an example of a grant. But a capital program is where money is given, but you expect it back. Okay, so and you expect returns, etc. Right? So that is an example of all kinds of capital that lands on balance sheets. So like debt, equity, and so on. So the idea is that this is a non-grant patient capital program that is only for the private sector, not for academia and so on. And the idea is that this will drive up translation and scaling. Okay, but I know there is an overlap region between TRLs 4 and 6, and some of our grant programs support some of those 2 to 6 transitions. And then they have to pivot over to RDI and then work with the private sector for scaling it up. So that's the theory of the case. And just to give you a sense of the programs here, this is 1 lakh crore, or roughly 12 to 13 billion dollars, and this is a 50,000 crore program on SNEC. So this is serious investments that are being made, and some of these also will drive further co-investments from industry, and so that's why I would be pleased to see if any industry would be willing to partner with us in various ways, right? And there are different ways of partnering. You could partner with IISc or the other IITs or any other institution which is submitting grant programs to us, and that's what is called a consortium mode or a bottom-up type of partnership. That's good for small-scale partnerships. We are also going to be doing programs where we are having research visitorships where individual people, just like we do fellowships, we are going to be effectively doing fellowships for folks to visit industry or startups and spend time doing work there for anywhere from 2 months to 12 months. And that's an example of a people-oriented program we'll be doing. And but this is the basic idea. So the idea is that this is for private sector, this is more for the academic, and so this is private-led, and think of this as academia and research-led, right? So that's the basic concept. But our goal is to be a catalyst, not a crutch, okay? A catalyst for the rise of India as an R&D powerhouse, okay? And on the grant side, we have 2 approaches. One is horizontal, which is broad-based programs where we don't tell PIs what to do. These tend to be smaller programs. For example, we have decided recently on a ARG or an advanced research grant program, which some of you might have submitted proposals to. The decisions will be communicated this week. So we fund literally hundreds of grants at small scale. There is some grants under 1 crore, the other grants up to 5 crores, and so on. And then we have more vertical programs where we have more mission mode focus, and these are directed in specific areas and so on. Okay, and we are increasingly pulling in partners to come earlier in the TRL levels and partner further. And some of this could be in terms of co-funding, some of this could be as collaborators. For example, in our ARG program, we have a concept of honorary PIs where they can come and collaborate. And there could be some funds set aside for the collaboration as part of the program, but we don't send money to the private sector in this, right? So we are trying to lower the barrier for collaboration, and also the same thing can be for international collaboration as well. And we welcome partnerships with foundations, CSR, family donations, and so on and so forth. You'll be seeing many more initiatives along these lines as we go forward, right? So another way to look at this is our horizontal program are like the foundation of a building, and our vertical program gives specific vertical focus. Okay, so we have vertical focus around uplifting our science and technology research ecosystem through programs like the PAIR program. So IISc is one of the PAIR hubs and or the 7 networks that are there, and there are spokes, about 7 institutions each. So about 45 odd institutions are there. Many state universities are involved, and so on. Mission mode is for sector-oriented investments, and then we'll be also announcing some programs around industry academic collaboration type programs, consortium programs for translational research, for industry academic collaboration consortium, inspired by what we have learned in many other geographies. And then finally, as an apex institution, we'll be doing a few things across the nation. For example, we have a program called SARL that we are partnering with. We'll be doing national dashboards, and we'll be sharing best practices and so on and so forth as part of what we do. And we will also set this benchmark for doing ease of science and better research grant management and so on, so that other entities can learn from us, right? So that's the idea, and this is all for the grant programs, and of course this RDI. So in our vertical mission mode programs, these are typically in sectors that we have picked out. These are the current examples, and this is not static. These are the ones which we have booted up in the last few months. There are many more coming in the thing, so there'll be more sectors. Typically, the way we do these programs are we partner with one or more of the ministries or departments, and we co-fund that program from the ministries and departments, and then we also invite external participation from foundations and so on. Just to give an example, a medtech program involves ANRF partnering as an apex organization with ICMR, Indian Council of Medical Research, and we also have a big partnership with the Gates Foundation. We also now, Vadhani Foundation has also indicated interest in co-funding some of our projects here. So this is an example of how it's all of government, all of society type partnerships, and this allows us to not only expand our budget in this specific program, I'm able to also support some startups directly with grant programs. So this private capital allows us to broaden beyond our core base of funding as well. Going forward, we have done a 2D materials program which just closed yesterday. There is one on AI for science and engineering I'll talk about shortly. We are going to be launching this week critical raw materials program shortly, and there'll be a drones program coming up in a month or in a few weeks. And these are some example programs. There is also another class of programs is around societal programs. We might take one or two of these areas and do a full-fledged program around it, but we may also have broad-based societal innovation and leapfrog innovation. But the goal here is to really drive technology-driven transformation of these areas. And as you can see, these are typically cross-disciplinary, cross-ministerial, right? And these are incremental to other things. Like, for example, the quantum mission will continue under DST, the geospatial mission, etc., will continue, but where they would like to partner with us on expanding their mission beyond what they're doing, they're welcome to come and talk to us. Similarly, hydrogen and so on will be done by MNRE and so on. So another thing we're doing is to democratize research using AI and social media. This is a piece of work inspired by Google's Notebook LM, but we are essentially converting papers into videos, into secondary media of all kinds, podcasts, multiple languages. Recently in our December release, we also have released support for paper to reels, right, on Instagram. And we support 19 different languages in partnership with Bhashini. Going forward, we will also be supporting posters automatically generated from papers. And then we are already currently supporting PowerPoint presentations and also some customization with templates and so on and so forth. There will be other future things like blog articles, and we currently also support patents as well, patents to things. So the idea is that this will allow democratization of research and making research content, primary research content, much more easily available and accessible. So we'll be doing campaigns with different entities like, the IISc could take its top 100 papers and make it done at an IISc level. Similarly, every other institution can do it, or IACS and etc. Different Indian Academy of Sciences, etc., could do something for them. INSA could do based on their papers, etc. So we are talking to CSIR also to do it along with an expert and so on. So look, we'll be doing many more things here. We are talking to the patent offices to take all the core patents and then make it available and so on. So we'll be doing many institutional things, and we're also setting up open data platforms for sharing data and ultimately open publishing of various sorts, so that and also a community platform to be able to discover people to sort of collaborate better and so on and so forth. So these are all part of our Apex activities. Okay, coming to AI for science and engineering. I'll be very brief here. So here, this is a very specially designed mission mode program where we have actually multiple programs as part of this. One is AI for science, one is AI for engineering, AI for weather and climate, and AI for bio and life sciences. The reason we have done it this way is that each one has some partnerships with the individual departments. For example, DRDO partners with us in AI for engineering design and accelerated material development. And so there is a partnership with the Ministry of Earth Sciences for weather and climate modeling as part of their Mission MAUSM program with DBT and so on, and some of our other foundations like Gates Foundation, etc., partner with us. We have partnership with BharatGen, we have partnership with Sarvam AI, who are providing us, they are technical partners helping us across the spectrum. MIT is providing us GPU capacity, and then we'll also be launching contests. These are open source contests, and one of the key aspects of this program is that every everything will be open source. There'll be open source models, open weight models, there'll be open data sets, and so that we sort of go beyond the balkanization of data sets. And we'll be trying to make all these things coherent so that both our scientists and engineers start adopting AI, as well as discover new ways of expressing their work in AI, and also discover new ways of AI modeling science and engineering. Right. So the purpose of this program is not just yet another foundation model for general knowledge management, but really direct modeling of science and engineering, and to accelerate the process of science. So as you all know that science and engineering is going through a huge revolution now, where going beyond classic knowledge modeling, the same techniques used in ChatGPT and diffusion models and reinforcement learning and so on can be applied in different ways for specific scientific problems. For example, weather forecasting or neural operators that are modeling partial differential equations of various kinds, or diffusion models that can be used to drive molecular simulations, and so on and so forth. And Sashi is also driving many things in his company and their work. Similarly, for biochemical and drug discovery and so on and so forth. In my past work, I've also done on various sorts of diagrams, flowcharts, PNID diagrams, text to PNID generation. All of these are used for chemical processes, mechanical processes, and so on, right? So the idea of complex multimodal modeling, diffusion modeling being used for a specific class of simulations, neural operators being used for partial differential equation and other sets of physical modeling, all of this can both dramatically accelerate the pace of doing HPC, and even though it has an approximation error, so the very fact that you can do it 3, 4, 5, 6 orders of magnitude faster means that you can essentially do Monte Carlo simulations and deal with all these approximation errors. Plus, you can start using these more sophisticated physics-driven models directly in digital twins in operations as well, right? So today digital twins are simple machine learning models. They can now become complex models. They can become knowledge-based entities. They can also be directly modeling the physics of the situation and so on, right? So this further can be complemented with various other things that are in terms of virtual labs, virtual testing, and the entire process is being accelerated, so that you can accelerate, drug discovery processes and other processes which are taking really, really long time. Similarly, more generally, I would say that the process from deep science to deep tech and ultimately market impact is quite long and unreasonably long. So both the discovery of science as well as going beyond the science to moving from deep science to deep tech, as I call it, and accelerating this process is what we are aiming at. And then the program is designed so that it can support all of these things. We also support some degree of validation in our program, so you can have experimental work beyond just building models, and also data generation and coherent data sets, gold standard data sets, which we support in our program. So, but the only key thing is that this is an AI program, not a cryo-EM program or something like that. So sometimes people would like to use these programs to basically just do science without the AI. I mean, those sort of things we'll throw out of the consideration. Further, as part of being open source and so on, we are also trying to drive combinatorial innovation. So the idea is that whatever techniques you use or develop new techniques, and whatever domains you use, we are having like an open stack of models that we'd like to do. And also AI is now at a level where once you have open models, well-defined model cards, you can now have agent builders which can automatically build workflows and agents that can cut across this, read up millions of models, and automatically build combinatorial, sort of solutions or AI agents, if you'd like to call it that, going forward. So, so that's one of the reasons why we are pushing for a completely open, sort of things. And this will be a contribution from the India to the world as well. And we are inviting several foundations to co-fund with us, and we'll be announcing more partners as we go along. Anyway, so this is my last slide. I don't want to go further, but I think the key point is that there are different techniques that directly model science. There are techniques that can help accelerate specific subsets of scientific processes. Some of the techniques developed for diffusion and other things for generative modeling are now applicable for generative simulation and generating candidates from target distributions. Now, HPC is going to get transformed. CAD or computer-aided design, computer-aided simulations, computer-aided manufacturing, all of these are going to be completely transformed going forward, but probably in more of a hybrid way, forward problems, inverse problems, all of these can be potentially driven, etc. Right. So I think this is a huge new area, and therefore we encourage activities, and really we would like India not to miss this bus, and really get on with it. And really, this is also another way to transform our scientific enterprise. Okay, so I'll not go further, but the idea is that the whatever is the loop of science or the entire scientific process. Now there is foundation models and operator learning, scientific ML, and many other tools and techniques coming through. So there's an opportunity for really discovery frameworks, as well as sort of even code generation for scientific applications can be accelerated through AI, etc. Right. So I'd like to pause here, and obviously whether it's mathematics or discovery of new science, I value theory as much as I value experimental work. But our goal here is to really enable and catalyze our community to get going on the space. All right. With that, I'm open for questions.
Yeah.
Happy to.
Thank you, Shiva. And of course, the last two slides, we cannot have a better slide to summarize the conference, CASML conference, than the last two slides there, which rightly put out, right, what we are really trying to build. So AI for science and engineering, of course. Thank you for making time to share the ANRF's platform, the ideas, a lot of initiatives. And I know that we have been complaining about the gap between industry and academia. I would say that the ANRF is the right platform now with this leadership of Shiva, right? Definitely we are going to bridge the gap. And I see that a lot of initiatives are going to come, and then we'll get it implemented. So now it's time for a couple of questions. If you have, of course, you will be having a lot of questions because he is sitting with the funding and policies.
There's actually, my slides may be shared with.
Yes, we have already the WhatsApp group, Shiva. We have already shared it. Everyone will be having. Everyone is having, all participants. Yeah, you want to add? Okay, I will add it after the. Yeah, any question? Looks like everyone is having a lot of funding. No need funding. Yeah, please.
So for the students who are studying at IITs or IISc, if someone who is doing research in scientific machine learning and physics informed machine learning, so how these initiatives or research people can reach out to ANRF or have funding and collaborations? So that is my question. Is there any schemes that is there by which we can reach out?
So look, I think individual students don't submit proposals. The proposals are submitted by faculty members and some particular classes of people, such as people who might have Ramanujan fellowships or Inspire fellowships and so on. These are the people who would submit proposals. So you have to be a institutional affiliation of that kind and a permanent appointee to submit proposals. But then obviously once one has grants, then that can be availed to support students, PhD students and so on. And also we are going to be renaming our JRF, SRF to ANRF PhD fellows and so on going forward, so that effectively we are supporting project-based PhD fellowships, project-based postdoctoral fellowships, and like our RAs and so on and so forth. So we'll be coming out some guidelines for all of that, and all our facilities will be national facilities and shared and so on. So we're going to be pushing for funding of sorts. So you're welcome to obviously work with your professors and so on. You don't have an option to submit directly to ANRF, but that said, students could take leadership in the contests and those sorts of tracks that I mentioned. So we'll be announcing contests shortly in our program. So student clubs and so on could take a leadership in some of those areas. And also, I would also encourage you to take leadership in the social media. Take your papers, use Saral, convert it into media. I've been pushing faculty with very limited success. I've also promised to read, their papers, even only if they convert to Saral. But even so, I'm getting very limited thing. So next time, I'm going to put a hammer and say that you have to, sort of do it. Otherwise,
funding. You have to put the funding decision also should be.
I had to figure out more compelling ways of. So, but students can, take leadership in many other things. We'll also be doing many more capacity building and other things. So look, I think it's a fair point, but while you cannot submit proposals, we'll look for more engagement models for students. And I would like each of you to build your own brands. Okay, be a leader in using Saral, be a leader in giving talks. You may have student talks and you put that on YouTube, okay, and tag us on ANRF, right? And we will amplify it, right? So I would love to see a lot more vibrancy in the community, and we'd be very happy to celebrate your successes. Our goal here is to help amplify, celebrate, and the research enterprise of India.
Thank you, Shiva. So one more very quick and short. Yeah.
So thank you, sir, for this presentation. So when in one of your slides, you mentioned that AI shows faster simulations. So in one of your slides, you mentioned AI shows faster simulations, but from my experience, whatever I have witnessed, so AI takes lots of time for training the model. For example, computer vision models, it takes days and days, even on GPUs. However, the traditional techniques that we have, numerical or mathematical, so they are comparatively faster. So in what sense did you say AI shows faster simulations?
Yeah. Look, I think there is training time and there is inference time. I think the point is well taken. Okay, so see, at the end of the day, AI has to be trained, and then once it's trained, your surrogate simulations at various scales are much faster. Please read the literature on neural operators and so on, which are there, and it's well established now that AI can be, you can have 1 million times speed up in those areas and so on. But there are trade-offs in accuracy and so on. But this space is very, very fast evolving. So it's not like an either or argumentative discussion here. It is just a fact of the matter that forward pass of the neural network is much faster than doing a HPC simulation at scale, especially if you want to do fine-grained FEM meshes and so on. Right. So the real question is, what is the right trade-off? You might use one approach for the other. There can be a hybrid model. So I personally believe that it's going to be a hybrid combination of classic numerical simulations and AI surrogate simulations, and one can validate the other, etc. And even you can do experimental validation. Experimental validation itself can be made high throughput, robotic, and so on and so forth, right? So this is all a direction of flow of changes that are happening, okay? So it is not at any point in time, any specific technique, one might be faster than the other. So I think it's irrelevant to talk about that. I think what matters is just look at the flow of the broad, sort of community that is going in this direction and take a broader view there. Okay, that's what I was trying to say.
Okay, well said. And in fact, that's the primary focus of this conference as well, right? So to explore more and how can accelerate, right, AI simulations. And in the interest of time, I know there are many questions, but there will be a WhatsApp group. You can also post your questions there, right? There are like other feeds also will be shared. Please feel free to share your questions and hopefully we will also get an answer. And thank you, Shiva, once again for joining and sharing the initiatives, and definitely like next event we want to have you in person here.
Sure.
Thank you.
And if I can just make a final plea,
Sure, please,
I want
go
each one of you to kindly follow ANRF.
Yeah.
Okay, so we are on LinkedIn, we are on Twitter, we are on Instagram, we are on Facebook, we are on YouTube. Please follow us, okay? Yeah. And I would like, and as you make each of your communities, you do different things, and we are also going to be on WhatsApp, okay? And in RTI, okay? So we are also going to have channels and all of this. Please follow us so that you can engage with us in various ways, as well as we want to celebrate your successes. So please, as you do your things, please remember hashtag ANRF India. Again, I'll repeat, hashtag ANRF India. Please use that and in your communications on social media. Okay, social media should be a first-class platform for technical dissemination of secondary media. Okay, thank you very much. Bye.
Thank you once again. Let's thank the speaker once again. Thank you, Shiva.
Thank you for that.
Yeah, thank you.